Hi, we're going to look at solving compound inequalities. We've solved inequalities before, which have been just single inequalities, something like x is less than 5. And we've been able to graph that on a number line. And we did this when we were getting ready to talk about domain and range. So we put the number 5, because our inequality did not have the equal to symbol, we would make an open circle. And now it's saying all the numbers less than 5. So that would mean everything to the left here. And that actually helped us to write our interval notation, which would say this is going from -infinity and infinity, reminder. So this little section here in interval notation would say from -infinity up till 5, and we would use a parenthesis instead of the open circle. So again, a reminder about some of our symbols that we use. Greater than, less than, and open circles were all related, as well as the parentheses. And later on, you'll see even the dotted line when you're talking about inequalities sometimes. And then that is in contrast to when you have that equal to, we'll talk about stuff with like a closed circle, and that's when we have the brackets, and we would have more of like a solid line. So now what we're doing is compounding the inequalities, which means putting more than one together. So we're still going to solve them. So they're solved just like regular equations. So I'm going to subtract a 1, but it's almost like you ignore what's going on over here. So we subtract 1. And then you're going to get -10 is less than -2x. Now the only difference with inequalities, if you remember, is when you divide by a negative or multiply by a negative, you end up flipping the inequality. Now, it's a compound inequality, meaning there was more than one. I crossed off one of them, but really what you're doing is solving. Let me erase my little cross off and cross this off, and then you're going to solve that guy. So what we can do is just solve them at the same time, because it's going to follow the same steps to isolate x. So you would -1, which would make 12, and then you would divide by -2, which would make greater than or equal to -6. So again, we had to flip the inequality here because we were dividing by that negative number. So what we're saying is 5 is bigger than x, which is bigger than or equal to -6. So one thing to always check for when you have these compound inequalities, especially if you're doing that division by negative, if your final kind of outside ones make sense, is 5 bigger than -6? Yes, so that checks. And so what we're talking about on a number line is all the values between 5 and -6. So -6 is smaller, so I'm going to write that over here. 5 is bigger, so I'm going to write that over there. And x, you can like visually see it sitting between those numbers. So it's going to be all of the values inside here. Now we can equal -6 because of the equal to right there. And we cannot equal 5, so that's going to be an open circle. So in interval notation, we're saying all the numbers from -6, including -6, to 5, not including 5. So then let's look at number 2. Number 2 is a compound, but instead of writing it all as one, it has the word or between it. So it's saying either this could be happening or this could be happening. So I'm going to multiply this side right here, both sides, by -4 to cancel out the negative and the 4. So that would become an x. Because I did multiply by that -4, I got to flip my inequality, so that will be less than or equal to, and I'll have to multiply on the right side by that -4 also, so we'll get -4. So we're saying that x is less than or equal to -4, or we'll do the same thing on the right side. We have that fraction, multiply by -3, multiply by -3 to make those cancel. So we get x, and again, our inequality had to change because we multiplied by a negative value. So our x's are greater than or equal to, and that would become -3. So we're saying x lives here or x lives here. So let's see what that's talking about on a number line. So I'm going to put my big important numbers, which are -4 and -3. -4 is littler, so I'm going to write that first, and then -3. So looking at the first inequality, it says the x's are less than or equal to -4. So we're going to have a filled in circle here, and we're saying less than, that would be everything to the left. For the second inequality, we're saying x is greater than or equal to -3, so we're going to close that guy in, and we'll do everything greater. I'm going to put my infinities on here to help with my interval notation. So remember that it goes negative infinity to infinity, little to big. So I have two intervals here. You're either living here or you're living here. This is negative infinity to -4 with a bracket. Or in math, we're going to write a little u for union. And then it will be -3 to infinity. All right. For number 3, we again have two different inequalities, but they're separated with the word and. And means where's their intersection or their overlap. It has to be satisfying both this first inequality and this second inequality. So let's solve them and see what happens. So the first one, I'm going to move the 4a over just because it's a little smaller. We'll have 8 is greater than 7a plus 15. Minus 15 minus 15, we're going to get -7 is greater than 7a. Divide by 7, we're going to get, just positive 7. We're going to get -1 is greater than a, which really means, and it's nicer sometimes to write the a first, which it's pointing to the a, so it's still going to point to a. So we're really saying a is less than -1. And we'll see what's happening with the other inequality. I'm going to add the 14a over, just because I like to keep things positive. That's 13 is less than or equal to 13. -3 plus 14 is going to be 11a. Well, minus 13, we get 0 is less than or equal to 0 plus 11a. That's just 0 is less than or equal to 11a. Divide by 11, we get 0 is less than or equal to a. Which again, I'm just going to write it with the a written first because we're used to that. It opens up to the a, and we're comparing with 0. So the and word, again, is important because it's not saying it could live in one spot or another spot, like wherever. It's saying it has to be in both. So let's see where -1 will be. -1 is smaller, so that's first, and then 0. So it says that our a values are less than -1. That would be everything to the left of -1, and open circle here. And then it says a is greater than or equal to 0. That's here. Now it's asking me and the overlap. So even just like thinking about it, is there a number that's less than -1 and greater than or equal to 0? Well, no. And it's seen here. There's no overlap. So we would actually have no solution here. And so our graph would actually just be like an empty number line because there's no overlap. Okay, let's see what's going on with number 4. We have the and word again. Let's see. We're going to move the 7t over, try and get all our t's together. That's 1t minus 13 is less than or equal to -2. Add 13, we get t is less than or equal to 11. And let's see what's happening over here. Let's move our t's over. So 20 plus 2t is less than 14. Minus 20, we get 2t is less than -6. Divide by 2, we get t is less than -3. So let's look at what's going on with our number line. We'll put our important numbers on here. We have -3 and 11. So I have that t is less than -3, so that's open circle going to the left. T is less than or equal to 11. That's closed circle, and then everything to the left. And so then the question is really, what's the overlap? And so you can see the overlap is happening right here. -infinity. There's our infinity. And so we're going to say from -infinity all the way up to -3, not including -3, is going to be the overlap, the and part. And my graph, just to kind of simplify it, is going to be all the numbers less than -3. I would just have that overlap graphed. Okay, for number 5, we're back to the word or, so there doesn't have to be overlap. We're just kind of seeing which parts we are in. So I'm going to minus x again, minus x. I always like to take away the smaller number so I have a positive variable, but you don't have to do that. And so -4, so I'm going to get 14 is greater than or equal to 7x. Divide by 7, we get 2 is greater than or equal to x. But really that's just x is less than or equal to 2. Or on the other side, well, minus 15x, we get 0 minus 15 is less than or equal to 5. So all our variables canceled. So it says is negative 15 is less than or equal to 5. Well, this happens always. This is always true. And so if that's always true, that means any number will work here. There's no dependency on a variable. So we're saying x is less than or equals to 2, or x is any number. So if x is any number, or x is less than 2, really we're saying that you can be anywhere on this number line at all, and you would satisfy at least one of those equations. So that's going from negative infinity to infinity. All right, let's try one more. Again, we have another or one. That's minus the 12. Minus the 12, we get negative 4n is greater than 32. We'll divide by negative 4. Divide by negative 4, we get n is less than. So we have to change the sign because we just divided by a negative. That would be negative 8. Or, well, minus the 10, we get 12n is less than or equal to negative 48. Divide by 12, we get n is less than or equal to negative 4. Now this one I did not have to change any signs because I didn't divide by a negative. So let's see what that would look like. We have to live where n is less than negative 8 or less than or equal to negative 4. So on my number line, putting my big important numbers, I have negative 8 is less. I'm going to put that first and negative 4. So less than negative 8 would be everything this way. Less than or equal to negative 4 would be everything this way. So now we're not looking for overlap this time. What we're looking for is being at least on one of those lines. So really, that's this whole deal. So that will be negative infinity to negative 4 will satisfy at least one of those equations. So again, the number line for that would be from negative 4 closed and then everything to the left. That would be our graph.